Navigating the Skies, a comprehensive analysis of satellite internet services over the last 20 years. Introduction. Over the last 2 decades, satellite internet services have undergone a remarkable transformation, evolving from niche technologies to critical infrastructures that connect millions globally. This comprehensive analysis explores the key developments, technological advancements, market dynamics, and regulatory challenges that have shaped the satellite internet landscape from the early 2000s to the present day. Key developments and timeline. Early 2000s, limited bandwidth and high latency. In the early 2000s, satellite internet services were primarily characterized by limited bandwidth and high latency. Providers such as HughesNet and WildBlue emerged to cater to rural areas lacking access to traditional broadband services. However, users faced challenges such as slow speeds, high costs, and a lack of reliable service. The existing geostationary satellites operated at high altitudes, resulting in latency issues that hampered real-time applications like video conferencing and online gaming. Mid-2000s to 2010, transition to Ka-band satellites. The mid-2000s marked a turning point in satellite internet technology with the introduction of higher-capacity Ka-band satellites. These satellites allowed for better data transmission rates and improved service quality. Viasat's launch of the WildBlue 1 satellite in 2004 exemplified this shift, offering faster speeds and greater bandwidth. Additionally, hybrid satellite terrestrial networks began to emerge, which combined satellite coverage with ground-based infrastructure to enhance service reliability. 2010 to 2020, the era of low Earth orbit (LEO) satellites. The introduction of low Earth orbit (LEO) satellites during the 2010s represented one of the most transformative advancements in satellite internet. Companies like SpaceX launched the Starlink project with the goal of creating a constellation of thousands of LEO satellites. This new architecture significantly reduced latency and increased bandwidth, enabling satellite internet to become a viable option for urban users as well. By deploying satellites at lower altitudes, around 550 kilometers, the latency was reduced to levels comparable to terrestrial broadband. 2020 present. Surge in demand and market competition. The COVID-19 pandemic accelerated the demand for reliable internet connectivity, leading to a boom in satellite internet adoption. SpaceX's Starlink service gained significant traction, with users reporting speeds that rival traditional broadband solutions. Other players such as Amazon's Project Kuiper and OneWeb entered the market, intensifying competition and driving innovation. Common themes in satellite internet evolution. Increased accessibility. One of the most significant impacts of satellite internet has been its ability to bridge the digital divide. The expansion of LEO satellite networks has enabled high-speed internet access for remote and underserved regions, empowering communities that previously had limited connectivity options. This increased accessibility has been vital for education, telehealth, and economic development in these areas. Technological advancements. Technological innovations have been at the forefront of satellite internet evolution. Multi-beam satellites and frequency reuse techniques have enhanced service quality and capacity, allowing providers to serve more users simultaneously. Additionally, advancements in antenna technology and user terminals have improved the user experience, making satellite internet more attractive for a broader audience. Regulatory and policy challenges. As satellite internet services have expanded, they have also raised concerns regarding regulatory frameworks, spectrum allocation, and international cooperation in satellite management. The proliferation of satellites in space has led to discussions about space debris, orbital congestion, and the need for sustainable practices in satellite deployment. Regulatory bodies are grappling with how to manage these challenges while promoting innovation. Market dynamics and competition. The competitive landscape of satellite internet has transformed significantly over the past 2 decades. As major players like SpaceX, Amazon, and one web vie for market share. The focus has shifted towards delivering higher speeds, lower latency, and greater coverage. This competition has resulted in increased investment in satellite technology and infrastructure, leading to rapid advancements and improved service offerings. Differences between sources. While numerous sources highlight the transformative impact of LEO satellites, they often differ in their emphasis on specific technologies and market dynamics. Some focus on the implications of satellite internet for global connectivity and economic development, while others delve into the technical specifications of satellite design and deployment strategies. This diversity of perspectives enriches the understanding of the satellite internet landscape and its future trajectory. Conclusion. The evolution of satellite internet services over the last 20 years showcases a remarkable journey from limited offerings to essential infrastructure that supports a connected world. Driven by technological innovation and increasing demand for connectivity, satellite internet has become a critical tool for bridging the digital divide and empowering communities globally. As the landscape continues to evolve, ongoing advancements in technology and the competitive environment will likely result in further enhancements in service quality and coverage, reflecting the critical role that satellite internet plays in today's digital age. References. 1. Wiley Online Library, Satellite Internet Evolutions / onlinelibrary.wiley.com/doi/10.1155/2019/6243505. 2. ResearchGate, Digital Transformation in Satellite Service /www.researchgate.net/publication/377930760 Navigating the Digital Skies, a comprehensive study of digital transformation strategies in the airline industry. 3. Science Direct, Technological Advancements in Satellite Internet /www.science-direct.com/science/article/pi/s24058440240982444. This analysis captures the significant developments in satellite internet services over the last 2 decades, highlighting key trends, technological advancements, and market dynamics shaping the industry. The future of satellite internet looks promising, with continued innovation and competition likely to enhance connectivity for users worldwide. Counterintuitive information regarding the evolution of satellite internet services over the last 20 years includes: 1. Urban versus rural focus. While satellite internet began primarily serving rural areas due to a lack of traditional broadband, advancements in technology, particularly with low Earth orbit LEO satellites, have made satellite internet increasingly viable for urban users. This shift challenges the long-held perception that satellite internet is only for remote areas. 2. Latency improvements. Traditionally, satellite internet was synonymous with high latency, often making it unsuitable for activities like gaming or video conferencing. However, the introduction of LEO satellites has drastically reduced latency to levels comparable with terrestrial broadband, contradicting the belief that satellite internet cannot provide timely data transmission. 3. Cost dynamics. Initially, satellite internet services were seen as expensive, limiting their adoption. However, increased competition from companies like SpaceX and Amazon has driven prices down, making satellite internet more accessible and affordable than many expected, which undermines the notion that satellite services are inherently costly. 4. Technological complexity. Many people view satellite technology as overly complex and difficult to implement. However, advancements in satellite design such as multi-beam technology and frequency reuse have simplified the deployment and operational aspects, making it easier for providers to offer high-quality services. 5. Regulatory environment. There's a common belief that regulatory hurdles would significantly impede the growth of satellite internet. However, the rapid pace of innovation and the increasing recognition of the importance of global connectivity have led to more supportive regulatory frameworks in many regions, facilitating rather than hindering growth. 6. Global connectivity versus national sovereignty. The expansion of satellite internet services has been framed as a means to bridge the digital divide globally. Yet, The proliferation of satellite constellations raises concerns about national sovereignty over airwaves and space, highlighting a paradox where increased connectivity could lead to geopolitical tensions rather than harmony. 7. Sustainability considerations. While satellite internet expansion is often touted as a solution for underserved areas, the environmental impact of launching thousands of satellites is significant. This raises a counterintuitive question about whether the benefits of enhanced connectivity outweigh the ecological costs, challenging the narrative that more satellites are inherently beneficial. 8. Market entry and competition. The entry of new players like Amazon and OneWeb has been viewed as beneficial for driving innovation and improving service quality. However, the sheer number of competitors can lead to market saturation, potentially resulting in service inefficiencies and financial instability for smaller providers. Countering the expectation that more competition always leads to better outcomes. These insights reflect the multifaceted and often contradictory nature of developments in satellite internet services, challenging conventional wisdom about the industry's trajectory and implications. In examining the report Navigating the Skies, a comprehensive analysis of satellite internet services over the last 20 years, several key aspects may be overlooked by most readers but are significant for understanding the full scope of this rapidly evolving industry. Here are the critical points that deserve further exploration. 1. The role of hybrid networks. While many discussions focus on the advancements in satellite technology, the emergence of hybrid satellite terrestrial networks is a crucial development that can be easily overlooked. These networks combine satellite and terrestrial infrastructures, leading to improved service reliability and coverage. By leveraging both technologies, providers can offer better solutions for areas with varying demand and infrastructure capabilities. Significance. Understanding hybrid networks is essential because they represent a transitional phase where satellite and traditional internet services can coexist and complement each other. This integration can enhance user experience, particularly in regions where purely satellite solutions may struggle due to latency or bandwidth limitations. 2. Impact on global connectivity and economic development. The report emphasizes increased accessibility to remote areas, yet it does not fully address the broader implications of satellite internet on global connectivity and economic development. The digital divide is not just about access, it involves the capacity for economic participation, education, and social inclusion. Significance. Satellite internet can be a game changer for countries with limited terrestrial infrastructure, enabling e-commerce, remote work, and online education. The potential economic uplift in these regions can lead to sustainable development, making this aspect vital for policymakers, investors, and communities. 3. Environmental concerns and space debris. The report briefly touches on regulatory challenges but may underrepresent the environmental impact of satellite constellations, particularly concerning space debris. The rapid deployment of thousands of satellites raises concerns about the sustainability of space activities and the risk of collisions. Significance. As satellite internet expands, the long-term viability of these services hinges on responsible space management. Understanding environmental implications is crucial for developing regulatory frameworks that balance innovation with sustainability, ensuring that satellite services can operate without jeopardizing space safety. 4. Regulatory framework and international cooperation. The mention of regulatory challenges could be expanded to highlight the complexities of international cooperation in satellite management. Different countries have varying regulations regarding frequency allocation and satellite launches, which can complicate global operations. Significance. The success of satellite internet services will depend not only on technological advancements but also on effective international legislation and collaboration. Policymakers need to address these regulatory challenges to facilitate smoother operations and ensure equitable access to satellite services across borders. 5. User experience and market dynamics. The report discusses technological advancements but may overlook how these advancements translate into user experience. Factors such as customer service pricing models and user interface design play critical roles in the adoption of satellite internet services. Significance: as competition in the satellite internet market intensifies, understanding user experience becomes vital for providers aiming to differentiate themselves. Companies that prioritize customer satisfaction and adapt their services to user needs are likely to thrive in a crowded marketplace. 6. Cultural and social implications. The broader cultural and social implications of enhanced connectivity through satellite internet are often overlooked. Access to information and communication technologies can influence social structures, cultural exchange, and community engagement. Significance: by recognizing how satellite internet affects social dynamics, stakeholders can better understand its role in fostering inclusion, global dialogue, and cultural exchange. This awareness can inform strategies that maximize the positive impacts of connectivity on communities. 7. Technological disparities among providers. While the report provides an overview of technological advancements, it may not delve into the disparities between different providers' technologies and their implications for competition and service delivery. Significance: understanding the nuances of different satellite technologies, such as low Earth orbit versus geostationary satellites, can help consumers make informed choices and drive providers to innovate further. This knowledge can also influence market trends and investment decisions. 8. Future trends and innovations. Although the report captures past developments, it may not adequately address future trends such as the integration of artificial intelligence in network management or the potential for new satellite technologies like laser communications. Significance: anticipating future innovations is crucial for stakeholders to stay ahead of the curve. Understanding where the industry is heading can inform strategic planning, investment decisions, and policy development, ensuring that entities remain competitive and relevant. In conclusion, while the report provides a comprehensive overview of satellite internet services over the past 20 years, there are several critical aspects that merit deeper exploration. By focusing on hybrid networks, global connectivity implications, environmental concerns, regulatory frameworks, user experience, cultural impacts, technological disparities, and future trends, stakeholders can gain a more nuanced understanding of the satellite internet landscape and its significance in a connected world. 1. Technological advancements in satellite internet. The evolution of satellite internet services over the last 2 decades has been profoundly influenced by technological advancements. The introduction of Ka-band satellites and the deployment of low Earth orbit LEO satellite constellations, particularly by companies like SpaceX with Starlink, have dramatically improved bandwidth and reduced latency. This has transformed satellite internet from a service primarily catering to rural areas into a viable option for urban users, providing speeds comparable to terrestrial broadband. Innovations such as multi-beam technology and frequency reuse have further enhanced service capacity and quality, making it essential to explore how these advancements have reshaped user experiences and expectations. 2. Accessibility and bridging the digital divide. One of the most significant impacts of satellite internet services has been their role in increasing accessibility, particularly in underserved and remote areas. Over the years, satellite internet has played a critical role in bridging the digital divide, enabling access to education, healthcare, and economic opportunities for populations that traditionally lacked reliable connectivity. The rise of LEO satellite networks has made it feasible for more users to experience high-speed internet, fostering discussions around the implications for social equity and economic development. An in-depth analysis of case studies from different regions can shed light on how satellite internet has transformed communities and contributed to broader socioeconomic growth. 3. Regulatory and policy challenges. As satellite internet services have expanded, they have encountered various regulatory and policy challenges. Issues surrounding spectrum allocation, orbital debris management, and international cooperation in satellite regulation have become increasingly prominent. The rapid growth of satellite constellations raises questions about how to effectively manage the space environment and ensure sustainable practices. An exploration of these regulatory landscapes can reveal the complexities faced by satellite internet providers and the implications for global communication infrastructure. Additionally, discussions on the need for updated policies to accommodate technological advancements in satellite deployment and operation are critical for future growth. For competitive landscape and market dynamics, the satellite internet market has become increasingly competitive, especially with new entrants like Amazon's Project Kuiper and OneWeb. This competition not only drives innovation but also influences pricing strategies and service offerings. An analysis of the competitive dynamics can provide insights into how companies are positioning themselves in the market, the strategies they employ to attract customers, and the potential for collaboration or consolidation in the industry. Understanding the market landscape will help stakeholders anticipate future trends and the evolving role of satellite internet in the broader telecommunications ecosystem. These 4 points provide a comprehensive framework for discussing the multifaceted developments in satellite internet services over the last 20 years, highlighting the interplay between technology accessibility, regulation, and market competition. 1. The launch of the Internet and development of commercial ISP services. 1990s. The advent of the World Wide Web in the early 1990s led to the establishment of commercial Internet service providers (ISPs). Early ISPs such as AOL and CompuServe provided dial-up access, which was slow and limited. However, this period marked a significant shift in how people accessed information and communicated, laying the groundwork for the broadband revolution. The technology evolved rapidly, with DSL and cable modems becoming the standard, dramatically increasing speed and accessibility. This transformation is reminiscent of the later advancements in satellite internet, where the demand for improved connectivity spurred innovation. 2. The Global Positioning System (GPS) development and expansion. 1970s to 2000s. Initially developed for military use, GPS technology became widely available to the public in the 1990s. This transformation allowed for precise navigation and location tracking, fundamentally changing industries such as transportation, logistics, and personal navigation. The rapid evolution and commercialization of GPS technology highlight a parallel with satellite internet, where initial military or niche applications expanded to become vital components of daily life and global infrastructure. 3. The mobile telecommunications revolution. 2000s. The launch of 3G networks in the early 2000s significantly changed mobile communications, enabling internet access on mobile devices. Companies like Vodafone and AT&T led the charge, expanding coverage and improving data speeds. The shift from 2G to 3G and eventually to 4G and 5G technology reflects the same trajectory seen in satellite internet services, where improved infrastructure and competition among providers have driven enhancements in connectivity speed and user experience. The mobile revolution paved the way for ubiquitous internet access, paralleling the increasing accessibility enabled by advancements in satellite technology. Future outlook, predictions for satellite internet services. As we look ahead to the future of satellite internet services, several key trends and predictions emerge that will shape the industry and its impact on global connectivity. These insights are influenced by ongoing technological advancements, market dynamics, regulatory developments, and user demands. 1. Expansion of low Earth orbit (LEO) satellites. The trend towards deploying LEO satellites is expected to continue, driven by companies like SpaceX, Amazon Project Kuiper, and OneWeb. By 2030, it is anticipated that thousands more LEO satellites will be launched, creating expansive constellations that will significantly reduce latency and improve bandwidth. This will enable satellite internet to serve not only rural and underserved areas but also urban centers, where competition with terrestrial ISPs will intensify. 2. Enhanced service quality and coverage. With advancements in satellite technology, including multi-beam antennas and frequency reuse, service quality will improve dramatically. Users can expect higher speeds, lower latency, and increased reliability. By the mid-2020s, it is likely that satellite internet will match or exceed the performance of traditional broadband services in many areas, making it a more attractive option for consumers and businesses alike. 3. Integration with 5G networks. The integration of satellite internet with 5G networks will enable seamless connectivity across different platforms. As 5G rolls out globally, satellite services will complement terrestrial networks, providing connectivity in areas where traditional infrastructure is lacking. This hybrid approach will enhance mobile broadband capabilities, particularly in remote locations and during emergency situations. 4. Diverse market applications. Beyond consumer internet access, satellite internet will increasingly support various applications across industries. Sectors such as agriculture, transportation, and disaster management will leverage satellite connectivity for real-time data transmission, IoT applications, and enhanced operational efficiency. This diversification will drive demand for tailored satellite solutions. 5. Increased competition and innovation. The entry of new players and the expansion of existing ones will lead to heightened competition in the satellite internet market. This competition will foster innovation, resulting in more affordable pricing models and improved service offerings. As companies strive to differentiate themselves, we can expect advancements in user experience, customer support, and service packages. 6. Regulatory evolution and spectrum management. As the satellite internet landscape evolves, regulatory frameworks will need to adapt to accommodate the rapid growth of satellite constellations. Governments and international bodies will collaborate on spectrum allocation and management to minimize interference and ensure equitable access to satellite services. The establishment of clear guidelines will also address concerns around space debris and sustainable satellite operations. 7. Focus on sustainability and environmental impact. Environmental considerations will play a crucial role in the future of satellite internet. Companies will increasingly prioritize sustainable practices in satellite design, launch, and operation, aiming to minimize their ecological footprint. Initiatives such as satellite recycling and responsible end-of-life disposal will become standard practices within the industry. 8. Global connectivity initiatives. Efforts to bridge the digital divide will continue to be a priority for governments and organizations worldwide. Satellite internet will be a key component of these initiatives, offering solutions for remote education, telehealth, and economic development. By 2030, it is predicted that satellite services will play a pivotal role in achieving global connectivity goals, particularly in developing regions. 9. User-centric services. Future satellite internet services will be increasingly user-centric, with a focus on customized solutions that cater to individual needs. Consumers will have greater control over their service packages, with options for varying bandwidth, latency, and data usage. Enhanced user interfaces and customer engagement strategies will improve overall satisfaction and retention. 10. Technological synergies. The convergence of satellite technology with emerging technologies such as artificial intelligence, AI, and machine learning (ML) will enhance operational efficiencies and optimize network performance. Predictive analytics will enable better management of satellite constellations, improving service reliability and user experience. In conclusion, the future of satellite internet services is poised for significant transformation, characterized by enhanced connectivity, increased competition, and a focus on sustainability. These developments will not only reshape the telecommunications landscape but also play a vital role in fostering global economic growth and social inclusion. As satellite internet becomes an integral part of the modern digital ecosystem, its potential to connect the world will be more critical than ever.